Alright, here is the first perfect problem for Math 111. Basically what it does, kind of tricky, it wants you to solve this equation by completing the square, but there's no numbers in here. We'll just use letters, constants, A, B, and C throughout the problem. So the steps will be, might help you to imagine what you would do if those were numbers, but really we're going to have to deal with these letters the whole way through. So here we go. So we'll start with ax squared plus bx plus c. The hint here is saying that we'd like to complete the square, but we can't because the leading coefficient here has to be a 1. So how can we make that 1? Well, we could divide both sides of the equation by a. So let's see, if I divide everything on the left by a, I'd get something that looks more or less like that. And then 0 divided by a would just be 0. Alright, and if that wasn't bad enough to look at, now we're going to try to complete the square on this mess. To complete the square, I'll put in these brackets because for me anyways it'll be really helpful to tell what in the world's going on here with brackets separating stuff out. So let's see, we always put an x here, and then what goes here is half of this number, half of b over a. I think I put that up in the hint. Half of b over a is b over 2a. So you get something like this. But then we have to put something here. What you put here is exactly this thing squared. So b over 2a squared, or b squared over 4a squared. 2a times 2a is 4a squared. Something like that. Plus c over a is equal to 0. So you have a couple of options. I guess these blinders aren't doing anything here. So maybe I'll write another step where I just get rid of those. X plus b over 2a squared minus b squared over 4a squared plus c over a equals 0. I want to get the x all by itself, so I'll kind of add and subtract these things over and get x plus b over 2a squared is equal to b squared over 4a squared. It's adding this to both sides, minus c over a, subtracting that from both sides. Alright, x plus b over 2a squared. Before I take the square root of both sides, I think it'll be helpful to have a common denominator over here. Common denominator will be 4a squared, so I'll have to multiply this by 4a and this by 4a, so that I have b squared minus c times 4a, or 4ac, that might start to look a little bit familiar, all divided by 4a squared. Okay, take the square root of both sides. X plus b over 2a equals the square root of all this mess. Make sure you put in the plus or minus. B squared minus 4ac over 4a squared. Then to get x by itself, we could subtract b over 2a from both sides. I'll write it in this form. Alright, we're almost done. Maybe we jump back up here. This right here could work as an answer. We've solved for x, but the problem is it says the answer should be the quadratic equation, so we have to figure out how to make this the quadratic equation. We're actually really close. We'll leave this maybe x equals, and we got negative b over 2a. And this square root here, I'll leave the top under the square root, but I can cancel out the square root on the bottom because the square root of 4a squared, that's a perfect square. That's just 2a. So to go from here to here, I said the square root of 4a squared is 2a. And now I have a common denominator, so I can put that stuff together and say I got negative b plus or minus square root of b squared minus 4ac all over 2a, which is the quadratic equation. If you're ever wondering where this came from, it just came from completing the square. Anything that you can solve using the quadratic equation, you'll be able to solve by completing the square. All we're doing is, instead of completing the square on the numbers, we complete the square on the letters here, and then plug in the numbers when we're using the quadratic equation. Just sort of changes the order you do things in. But anyways, that's the end of this problem. Some pretty tricky algebra in here, but kind of satisfying when you get the right answer, at least for me anyways.